All right, this is our assignment notes from January 12th. Okay, here we have to graph polynomial functions. Okay, and I'm going to walk you through a little bit of how the book does it, but then we're going to talk about how we use this graphing calculator you can see over here to the right. This you can download in the self-service on your iPad, or if you go onto the computer, just type in Desmos and you'll be able to click on graphing calculator and you can do this online. So let's look at how the book would have you do this, and I think this is a bridge too far personally. Before we do that, I do have to discuss this slide right here. One of the ways we talked about previously of describing graphs is we described their end behaviors. So what does it do over here? As x went this way, the function went up to infinity. And then we talked about the end behavior at the other end. As x went to negative infinity, the function went, in this case, down to negative infinity. Whereas this one is x went to positive infinity, the function went to positive infinity. Okay, so that described the end behavior. But what about in between those two ends? What does it do? And to describe the in-between part, in between the ends, we use the concept of increasing and decreasing. And when you're doing increasing and decreasing, just read from left to right. And by that, I mean start at the furthest left end, okay, and just start tracing the graph and just decide, am I going up, increasing, or am I going down as I trace it? And you can see I'm going up here until I reach this highest point. And so that region is called an increasing region. I reach that highest point and I turn around and I start to come down as I trace it. That's called a decreasing region until I reach this lowest point called a relative minimum. And then I turn around and I start to go up, so this is called an increasing again. So it's got three different regions here. And we can actually, if we have good numbers like in this case, we can actually describe these regions. Okay, so first this increasing region. Okay, look how it always increases till it gets to this point. Well, what's the x value at that point? That x value is 0 right there. And so this little region right here, this whole region, when x was less than 0, to the left of the 0, we could say the function was increasing. It was going up. Now this green region is actually trapped. It's trapped in between this 0, that's where it started, and then it stopped decreasing when x got to 4. So for the green region, we'd say when x was bigger than the 0 but less than the 4, the function was decreasing, when x was trapped in between there. And then our last region, where it was increasing again, that started right when x was 4, it started to go uphill again, so when x was bigger than 4, it was increasing, and it kept increasing forever, so it never turns around again. Increasing, awesome. Increasing, still not very well written. Okay, so that's how we can describe the inner parts of the graph. So we have a way to describe the ends and a way to describe the middle and have discussions about it. Now let's look at the way the book would have you graph these. So here's my function. It's a polynomial function. They all will be for right now. Okay, and the book would have you, as step 1, make a XY table. Okay, and we just practiced this in our second lesson, I think, of the semester. And we just pick a random x, although not completely random. I'd always start with 0. And we'd find the f of 0. So you'd have to substitute in a 0 for every x. And this comes 0, 0, 3 times 0, 0, negative 3. So if I was graphing this guy, I now have a point on my graph. 0, negative 3. 1, 2, 3. There's a point. Now I got to find more and more points. Now I do have some hints about what this graph is going to do, at least. but this is still going to take an inordinate amount of time. And what I mean by some of the hints I have are, I know it's odd, so because it's odd, it's either going to make this S or it's going to make this S. Either right side goes up or right side goes down first. And because it's negative, I know it's going to do that one. I know the right-hand side will be going down ultimately, and the left-hand side will be going up. So let's find another point. So now I would go, okay, what's the f of 1? And I replace all my x's with 1. You got your calculator and type this in. I'm just going to crank through it real quick. Looks like that gives me 0. So when x is 1, it goes through 0. Then I would have to try 2. And then I'd have to try 3. And then maybe I'd try -1 and -2 and -3. But you'd have to get a numerous number. You'd have to get numerous number of points to get any kind of decent idea of how to graph this thing. So what I encourage you to do is A, understand you can do this by generating tons of points. But better than that would be to use the technology that we have at our disposal. Okay, so over here on the Desmos side of things, I have it graphed. And all I do is type that in. Notice I can type in f of x to my graph. And I can use the, above the number 6 is a caret symbol. Looks like a little TP. And if you click that, it'll put you in the exponent spot. Then you can arrow over and you'll be back to the bases and you can type in the rest. You'll figure it out. It's pretty easy to do. Also, when you try to type something in, you do get a nice keypad. And so hopefully maybe you can see the buttons I push. If I typed in, I'm just going to go y equals x. And see there is an A-B button. It's right next to the 7, to the left of the 7. If I press that, it puts me in the exponent spot. And so I could then type it as an exponent. And then I arrow over. Okay, so take a look at that keypad. You'll figure it out. Now, the nice thing is about Desmos is when I touch points, if I hold my finger there, it will actually tell me the value. So there's my 0, 3, -3. There's my 0.10. And then we can use this to steal a few more points. Let's see here. There's a maximum right there at x is 1.3. So a little bit past, oops, a little bit past, let me pull him up again so I can see him. A little bit past the 1, at 1.3, it goes up to 0.4. So right about there. And we just estimated. That's way too high. Right about there. Just a little dip up. Then it turns around. Let's see if we can find that point. At 1.7, it hits the x-axis again. So right about there. See how I'm just ballparking this? Then when x is -0.7, it goes down to -4.3 about. So that's somewhere around right there. Let's find this x-intercept, -1.7, so right about there. And that's probably enough points, and I'm going to sketch it in. And it'll come down like this. Try and make it nice and smooth. All polynomials are nice and smooth. And there is my representation of the graph of that function. Okay, again, not perfect. I had some students who actually graphed it on Desmos like this, took a screenshot and pasted it on their paper they turned in. Let's go ahead and talk about increasing and decreasing just so we get practice with that. I will do increasing with red. I'm just going to highlight the regions. And I'll do decreasing in green. So let's see here. I start at the furthest left I can go, the very top of the graph, and see how I go down as I trace it. So it's decreasing here. I hit the bottom, and now it's going to increase. I've got to turn around and go up. So there's an increasing region, and then I come back down. So that's a decreasing region. Okay, it'd be hard to put numbers on this one, though, because I can't even, I'd have to pull them up on Desmos and have to get very particular about it to find these x values there and x value there. So for right now, if I was asking for that, you could just write increasing and decreasing right next to each of those. So you'd write decreasing here, and then here you'd have to slap in an increasing, and then decreasing over here again. Okay? Here's on this next slide, I just have pasted in that graph so you could see how some students did it. Okay? And they actually just threw in their Desmos graph. It's kind of okay. Not the best way. I think we do need to get practice in reading these graphs and stealing these points. One more example for you. It's this guy right here. So let's undo him. There we go. All right, I'm going to make an XY axis. Good, there's my X, or my Y. And let's see if I can get my X kind of in the middle. That's not too bad. And there's my X. Remember, it's always X. X and Y. All right, so we could generate a table of values. Like if I plug in 0 for X, it always gives you Y-intercept, 1, 2, 3, 4. Okay, I also know it's an even coefficient, so the ends go in the same direction, or an even exponent, degree, ends go in the same direction, +1. I know it's going up and up. I know that from the last section. And here I'm going to take a look at him in Desmos. He's the second graph there. That's what he looks like. And you can see the left and right hand side do indeed go up, just like we predicted. Let's steal some of these points. Okay, so there's my 0, 4. I already plotted him, my y-intercept. Let's find this x-intercept, 1, 0. That's where it crossed the x-axis. Let's find this lowest point. At 1.8, so almost a 2, it goes down to negative 4.3. So at 1.8, negative 4.3, somewhere around right there. Let's find this x-intercept. That's at 2.38. So 2.38, a little bit past the 2. Right about there. Then it goes up forever. Okay, let's look at, here's another good point right there. At negative 1.08, so almost exactly negative 1, pretty close. It's almost at 2. So right about there. All right, I think that's enough because then it goes up to the left forever. So let's go ahead and see if we can graph this guy in there. So it comes down like this. Does a smooth turn, goes up, comes back down, does a smooth turn, and goes up forever. So that's not a bad copy of the graph that Desmos gave me. Okay, let's do increasing in red. Let's do decreasing in green again. I think that's what I used last time. Again, I start on the furthest left and start tracing, and this thing is going down. So I'm decreasing, then it turns and it goes up, so I'm increasing, then it turns and it goes down, so I'm decreasing, and then I'm going up again for forever, so I'm increasing. So this one has 1, 2, 3, 4 different regions, 2 decreasing and 2 increasing. And then next slide, I've just drawn the graph so you could see it and you could ignore this stuff. I think that stuff is not relevant for this problem particularly. Just knowing the regions and where they're increasing and decreasing is enough. So the homework looks like so. Okay, the first 4 you're going to make graphs just like I did. Try to make them relatively accurate. Okay, nice and smooth. There shouldn't be any sharp corners or turns. And then in 5 and 6, you can actually do it like the second slide we looked at, where you'll be able to say, hey, when x is, in this case, less than, it looks like 4. What's the function doing? Is it increasing or decreasing? You'll have to answer that, okay? So you have to make that decision. And then there's another region over here when x is bigger than 4, so you have to state and talk about that. And then in 6, we're going to have 1, looks like 2 three different regions here. So again, look at slide 2 and it explains that. Hopefully that will help you guys out with this section.